Okay, the formatting on this problem didn't come through very well. So it should be good for your test, but it's really similar to the first problem. So just kind of follow that format and try to get through that one on your own. The next ones, the formatting is also not really great. But basically what you're doing is you're looking at it on the table. So on a table, just remember, it's probably just asking what the inverse is. So like these are switched. And that was our relationship on the table. And then down in here with the graphs. Okay, we really need to do this because we didn't talk a ton about how to do it. We talked about the relationship and how it reflected over this line. And this line is y is equal to x. And we talked about that line, and we talked about how it had a slope of 1 and the y-intercept is 0. So this is like this. So y-intercept of 0, right through the middle, with a slope of 1. So if this is an inverse, the inverse of this graph would flip over that line. This is hard to do. This is really hard to do, actually, if you're just eyeballing it. So in order to get it exactly right, you have to be just a little more strategic about it. So here's how I would do it. This point, I find points that fit nicely. So I would go like that, or kind of turning points. So if I can reflect those points accurately and connect them, I will have gotten the problem correct. So what I'm going to do is I'm going to make a table of what those points are. And this one right here is 3, 5. Okay. Now the inverse then, like we did above, is the opposite. And then you would plot those points. And voila. You can see how that, that's really an easier way to do it. So the other ones are a little trickier because this one on the left, all the points are really nice. Okay, the one on the right, you only get a few. So what you do is you go through and you highlight those. Okay. And then I like to draw this in there too, just so I'm sure that it looks like a mirror when I'm done. So I'd put those red dots on a table and just do what we did in the last problem. Same thing here and same thing here. Okay, now for the real meaty part of the test. So this is where you're actually finding the inverses on equations. So we had 3 steps to this. We made f of x equal to y. Then we switched x and y. Then we solve for y. So here I would have x plus 20 over 13 equals y. And this is the inverse of this. So we know what would happen if we put them in a table, and we know what they would look like on a graph. Okay, this one's a little tougher, so let's stay with the same thinking. Make this y. And switch x and y. Subtract 17. Okay. There's a lot of different ways to handle this, and this is where the problem would go wrong for a lot of people. So you need to divide both sides by -3/4, which a lot of you know is the same as multiplying by -4 over 3. And that'll work but I think that there's an easier way to do it. So here's how I look at this problem. So when I look at -3/4, I first look at this divided by 4, and I ask myself, you know, what's the opposite of divided by 4? And that would be multiply by 4. So if I multiply both sides by 4, all of a sudden, it's a lot easier. And now I get rid of the -3. And voila, I'm done. It's a lot easier than getting into fractions and decimals and things like that, okay? So again, I just undid the fraction by getting rid of the divided by 4, and then by the times 3. Let's see if there's any others here that I want to do. Yeah, these are a little tricky. I think I can kill 2 birds with 1 stone with doing 12 with you. So for 12, I'm going to make this j of x thing equal to y. And then I'm going to switch x and y. Okay. Now, what's the opposite of square root? Is squared. So I'm going to square both sides. And when I do that, all it does is it gets rid of the radical. Now I'll just do it like I have before. I'm going to add 15. Oops, I gotta add 15. Add 15. And then I'm going to divide by 3. This one's tricky. So I'm going to have this divided by 3. And that gets rid of this 3 here. And now I gotta take the square root of both sides. So before I do that, I'm gonna go 15 divided by 3, because what this really is it's 5 plus x squared over 3. That's really what it is. And that's equal to y squared. And now I'm going to take the square root of just that whole thing and be done. Okay, that one's really, that's pretty tricky. But all you're doing is just, you're just getting rid of, you're just solving for y by doing inverse operations. So that one's really tricky. I don't think you'll find the other ones quite as tough, but that does get you through most things. I do want to cover one of these. I'll pick the toughest one to do, so the last problem on the study guide. What is the maximum value of the function? So I'll reiterate this on the test, but let's see, are these going on forever? So I'm going to say that this graph is stopping here because it does not have an arrow, and it's stopping here. So the maximum is the highest value. So the highest value is the point, -3, 5. The minimum value is the point 7, -5. During which interval is the graph constant, using interval notation. So a constant area on the graph is like this, where it's flat and constant. So that's the only one that has a constant area. So this one is none, because it doesn't do that. During which interval is it increasing? Okay, this graph is going down and down. So the only spot that it's going up is here. So that is the interval from 0, parentheses, because it's a transition point, to 2, because it's a transition point, both have parentheses. During which intervals, oh, I'm sorry, I just answered E. Oh, no, I was right. During which intervals is it decreasing? Those are the blue regions. So that is from -3 Right here, it decreases to 0. And then also from 2 to 7. Now, if I'm being really nitpicky about it, the start points and the ending points, I use brackets. But that should get you through the rest of the problems and hopefully the whole study guide and ready for the test.